Let me come back to should component update and show it's important and why you might want to use it. Let's edit our app.js, our template a little bit, so that we have a demo use case. I'll add a new button above the cockpit. This button should always show the persons. So the difference to the toggle button in the cockpit is that it doesn't toggle it, hide them if they are visible, show if they are not visible, but always show them. And if they are already visible, it doesn't do anything. Or so you would think. So let's add an on-click listener here. And for brevity's sake, I won't create a new method handler. I'll execute this all inline here with an arrow function, which gets executed upon the click. There, I will call this setState, which I of course can do inline here too, and set showPersons to true. So always true. Again, no toggling, always true. The button's going to look ugly, but it'll do the trick here. Now let me go up all the way to should update, and there we should return true, always true. Now let's go to persons.js and also comment out our check here and instead return true here too, which would be the default if we don't implement should component update. Now let's go back to our application. There, if we reload it, let's click show persons. We see all the persons and it behaves as before. Now I'll clear the console, but I didn't reload the page. Let me click show persons again. Now what you see is that we go through all these life cycles again. Should component update for app.js, will update, render, persons will receive props, should it update, we return true, so it will continue, will update, render for all the person component. React goes through the full component tree and all the render methods, even though nothing changed. The persons didn't change, the array didn't change, nothing changed. Now, don't mistake this for React re-rendering the actual DOM, the browser DOM. It didn't do that. You can confirm this by going to Elements, and there, if you go to the options here on the right, go to More Tools, and then Rendering, you can turn on Paint Flashing to see areas that need to be repainted. If you do that and click Show Persons, you see only the button needs to be repainted. For Toggle Person, you see a lot gets repainted, but for Show Persons, this doesn't happen. So it doesn't touch the real DOM. It only, and that just happened because I hovered over it, by the way, and I'll disable this again. It only touched the button, it didn't touch the real DOM. And I will come back to how React actually does decide whether to touch the real DOM or not in the next lectures. But for now we can know that it doesn't necessarily touch the real DOM, only if it detects differences to what it sees in the render methods. But for that, of course, it needs to execute the render methods. And as you can see in the console, it did do so. It executed all the render methods. This, of course, is a bit inefficient, especially for bigger apps. Here, it didn't cost us much. But if you have a lot of child nodes, a very long list of persons maybe, going through all the render methods, even though nothing changed, really can be a performance issue. That is why prior to that, we had this check in should component update in the persons. I'll comment out true again and reintroduce that. Now here it really checks if there's a difference between the persons and only re-renders if it detects this difference. You can of course add the check for all the other properties too. So if next prop persons is different, or if next props changed, another property we have here, changed, is different to the previous implementation of changed. So if this is not equal to this, props changed. And finally, the same for next props clicked, if that is not equal to this props clicked. So if any of the relevant props changes, we now continue with the updating, but if no property changed, we don't go there. As you can see here, reload, clear, click show persons. We go through all the render methods, of course, which makes a lot of sense because we need to render the whole list. But if I clear this and I click show persons again, you see we are inside should component update of app.js, will update app.js, render app.js, because we always return true in should component update there. But then for persons.js, we are at will receive props, should component update, and we're done. We don't continue. We don't call render for persons and the individual person components, because we detected in should component update of persons.js that the props didn't actually change. So our click here didn't trigger a re-rendering or a call of render for all these components. It stopped in persons. Of course, we can do the same in app.js. Instead of always returning true, we can check if something actually changed in our state. So if our next state, persons, one of the states we have besides other state and show persons, so if next state persons is not equal to this state persons, or if next state show persons is not equal to this state show persons. With this check in place, we should now see that if I click show persons, we go through all the steps correctly, we render them. If I clear the console though and click show persons again, we only reach should component update and that's it. Because we detect, hey, nothing changed, I don't need to continue. If I remove a person though, it does correctly do so and go through all these steps. So this is the best possible way we can handle this right now, because we make sure that we only run through the updating process if we need to do that. And we skip unnecessary work and of course therefore performance hits if we actually don't need to do updates because we know, hey, the props didn't change. No need to do all of that. Now for this check where we see if the state properties, so all the properties in our state, or the props properties, so any property on the props object, if any of these change, this is a check we don't have to write on our own. If that is what we want to do, make this shallow comparison, and I'm saying shallow because it doesn't deeply check these objects. It only detects differences because we update them in an immutable fashion, which is important. So if we want to make this shallow check, we actually don't have to implement should component update. Instead, we can comment this out and inherit from a different type of component, a pure component. This is a different object exposed by the React library, and it is exactly the same as the normal component, but it has this type of should component update check already built in. It will basically go through all the properties in the props and compare them to their old versions, and only continue updating if it detects differences. And it does the same for state. So we can also set app.js to a pure component. So let's import pure component there too and extend pure component. With that, let's retry this. And yep, thank you for the error message. We should then remove should component update in a pure component because again, this is handled by React. So let's retry this. Show persons works. Clicking it again. We don't see the console log because we don't have our own should component update method, but we would see the console logs of all the other updates, as I can prove if I really change something. So we get the same behavior as before, but now optimized by React, by this automatic implementation of should component update. Should you then always use pure components for your entire application? And how does this make sense if I also tell you to use functional components as often as possible, where you can't use this because you don't extend anything? Well, the answer is you shouldn't use pure component everywhere in your application. You should only use it if you know that updates might not be required. On the other hand, you have components which might only depend on one or two props, and you know whenever an update is triggered for this component, I want to update it because maybe I got a couple of pure components at top positions in this component tree which prevent the updating of any child component anyways. So don't make everything a pure component because you also can get a performance hit there. In the end, this implemented should component update for you, and it compares all the old props and states to the new props and states. This of course also takes a bit of performance, and if you implement it somewhere where it will always succeed because you already did this check in a higher point of this component tree, then you're really hurting your application. So not everything should be a pure component. Some strategically placed pure components make a lot of sense though. Now, to find out where to place them, we need to get a better understanding of how React walks through our component tree and how it actually decides to really update the real DOM. Let's have a look at this in the next lecture.